Hi everyone, thank you so much for being here. We are really happy to host this meetup with Daft team. It's been a pleasure to work with them. As part of hosting, we also get to do a talk. Jay very nicely told you all about the multimodal data complexities and the processing side of the story. So now I want to address the data management and query side of what can you do when you have a lot of multimodal data to deal with. So at ApertureData we started building this. Sorry, hold on. My laptop keeps slipping, and it'd be a problem, huh? Mac would slip too. Anyway, that's a running debate I have with all the Mac, Linux, and Windows users. But anyway, so at ApertureData we've been building this foundational data layer to help AI teams not only jumpstart their multimodal AI deployment, but kind of 10x their productivity. And we've been lucky to work with Fortune 500 companies, in retail and e-commerce, life sciences. So we've learned a lot from the teams there. And back when we started building this, we were working with the AI teams at Intel Labs. And so we've seen, we've gone through the evolution from machine learning all the way today to AI agents. So I want to take you through the journey of, how we've picked up all the different, how we ended up making certain design decisions, where has that landed us today, and how we can help you build your multimodal data pipeline. So, back when we just started working on deep learning stuff, it was interesting because, if you first ran AlexNet, you could see how, I don't know if you can read it there, but it's calling the brain scan a dial telephone. So, but the promise was models could now detect what's going, what you're looking at. And if you gave it better data, you could expect better outcomes. I don't know if I can hide it somehow. Hopefully you can see it. And then we came to a time where multimodal models could actually detect what was going on in videos, and you could extract embeddings from a lot of different things and actually say things like, find me something that looks like this. And now, since last couple of years, we've actually been able to ask the models to generate responses for us, generate images, but of course, everything comes down to better data equals better outcome, which is why we have seen 16 different flavors of RAG going all from vector-based RAG to graph RAG to agentic RAG. Ultimately, all they're trying to do is get all these processes are trying to get hands on the right data and give you the right answer without hallucinating, if possible. So where are we today? Now, all everybody talks about are AI agents. I am waiting for the time when AI agents actually get physical embodiment and they start actually doing things that I don't like. But for now, I put in an e-commerce example there. A customer says, I want to buy a backyard umbrella, some mistakes in the query, but the agent chatbot is capable enough to go fix up the query, go looking, either through an MCP interface or query a RAG endpoint, and do a few iterations to fix up the results and give responses to the user. But what's missing there is, even though it was able to find umbrellas under 200, but if it is not exposed to all the data that actually goes into fulfilling an order, which means inventory management information, maybe there is some user feedback that it didn't account for, and maybe the customer that's asking the question has in the past, provided some preferences, like maybe they only like blue color stuff, or they only like, I don't know, really large umbrellas or something. But it kind of missed all that information because all of these things rely on disparate data sources being put together to ultimately create the response that the user needs for answering their questions. So if you tie all these pieces together, going through the different phases of AI development, what does that tell us? There are three key components in order to make human quality AI possible. It's multimodal models, its processing capabilities, and managing multimodal data. I think we are doing pretty well with the multimodal models. Processing is, at its best now, and there's so much you can execute. But why do we keep seeing text? Why is everybody operating on text? Jay gave us some preview of what the challenge is. Let me show you what the data management challenge is. That's literally a Frankenstein's monster in the data world. If you want to bring different data types together, you are very easily looking at metadata in a relational or a key value store. Data dumped in cloud buckets, which I kid you not, people don't remember how they named them, so they don't know how to go find, and then they have to go collect data again. I literally have been told that they keep collecting videos again and again because they didn't know how to find the old data. So you can say storage is cheap, but when you're talking about videos, you're gonna have to start paying up for it. And that's not all. You gotta make sure you correlate that information into the tables that you have created. I think someone asked a question about FFmpeg and what happens when you are actually accessing videos and you want just a little part of the video. You have to deal with the idiosyncrasies of libraries like FFmpeg. And that's not just all, that's just on the video side. What if you had audio? What if you had images? What if you had PDFs? That's the kind of Frankenstein's monster that you're gonna have to deal with, and this is an infrastructure problem. In fact, working with the Fortune 50 data science team, we did a computation. How much does it cost? Because it's very easy to say, well, people can just work extra hour and make that stitched together system work. But that's not the answer because it doesn't scale in production, and if you get the wrong results, your models are not gonna perform as expected. So the cost for a team of 10, when we computed with how much are you wasting, it came to $2 million a year, even without accounting for the excessive amount of cloud resources that you end up spending on this. And that's just one team. For any large company, there are multiple teams that are solving the same sort of problems, and they all stitch their own Frankenstein's monsters. And then the management asks, why isn't AI working for us? Well, it's hard to say. We didn't make the Frankenstein right. So what is our solution to the problem? We built ApertureDB from the ground up to address multimodal AI. It combines the capabilities of, for one thing, it allows you to put data from different sources of different types in one database that can then be queried for building various different applications, whether it's AI agents, Gen AI applications, or your classic machine learning training and inference pipelines. It's the first vector graph hybrid database that is purpose-built for multimodal AI. What do I mean by that? So let's first talk about multimodal data. And I'll show you with a demo what it truly means to understand multimodal data. It means you can actually introduce data types like image, video, PDFs and stuff into your database as first-class citizens. And which means if you go to access videos, you can say things like, I only want 20 seconds of the video from the 10th frame. And the database actually understands it. It does the decoding and processing and returns the required clip that you're interested in. The next aspect is the metadata. We realize that a lot of this data already comes with different metadata, whether it's just simple attributes like timestamp, or who is the owner or who is the creator, or you might have run models to detect where is a specific bounding box, where is a specific object, where are people's faces in the images, or where is a specific interesting paragraph in the document. All that stuff is metadata and it's very connected. So what we use here is a memory optimized graph database to represent the metadata. And it's not only that, as you start adding information, you actually build a knowledge graph of all of the application specific stuff and your data all together, which means you can actually start asking fairly detailed contextual questions on this data. And of course, none of the search and retrieval problems are complete if you don't enable semantic or similarity search on this data. So the third really key component is the ability to do vector search. You can index any dimensional feature vectors in ApertureDB and try out the different engines and distance metrics to find the data that you're looking for. And the beauty of this, of having a unified API that ties all of these things together, is not only can you do vector search, but in the same query, you can go over to properties and the structure in the graph, further filter the information you need, and get to the data you're looking for. So the same thing that you would have done 3 to 7 API calls to 3 to 7 different data tools, you do in one query to one database, which means you can do it at scale, you can do it often, and you can do it very efficiently. So that's what ApertureDB brings for you. And because of some of these design choices that we have made and the way we optimize the database, we have measured, comparing against some of the popular vector databases, 2 to 10 times faster vector search performance, 2 to 30 times faster graph search performance. Granted, the query comparison was with a database that's written in Java, but it works really fast. And then if you're dealing with actually looking at multimodal data set preparation, you can see 35 times faster access to processed complex multimodal data. And what does that result in terms of your teams? You get a 10 times productivity boost when you're not spending your days wrangling data to get started. You don't have to worry about scale. We have tested over billion scale graph, and we stopped at billion because cloud costs are really high to test bigger than that. And then the latency, we get vector search responses in under 10 millisecond. We have seen billion scale graph queries in under 15 millisecond. So whether you care about latency, throughput, or both, ApertureDB can address all those problems and still deliver the functionality you need. It's one database to build a lot of different applications, especially through the integrations we support. And these are deployed real-world use cases where, working on a multimodal RAG for a Fortune 50 retailer, how do you combine different things like product information, product images, user feedback, and all these things to give answers for better recommendations to customers, and how you unlock millions of dollars in revenue for them. We also have this really cool robotics use case where it's an inventory management case where the robot goes up and down grocery store aisles and does thousands of, actually 4,000 to 8,000 vectors per second. And they have to finish all of this within an hour in the morning before store opens. So this is basically how you can scale when you do the design choices right and still save time. Now, how do you deploy ApertureDB? You have a lot of different choices. We can do a VPC or your deployment in your cloud. We have our own self-serve cloud platform. You can bring your own cloud. And we also have a community edition, and we are also available on Google Marketplace. AWS Marketplace will come sometime towards the end of the year. I want to introduce this concept of workflows real quick. People would ask us, all right, I can store the data, but how am I generating embeddings? How am I doing object detection? So we ended up writing a lot of processing code. And this was, before I learned about Daft, so I think we could optimize some of that processing code using Daft ourselves. But essentially, these are templated functions, so you can literally say, okay, well, I want to generate embeddings on this data. It'll query the data that's in the database, embed it, put the embeddings back, which you can use for your RAG endpoints. So now let's see if I can show you what that looks like real quick. Okay, this is going to be a little weird because I have to look over there and, all right. So our cloud platform, you can go cloud.aperturedata.io. And you can see, you create an ApertureDB instance for yourself. You have a 30-day free trial, so you can try all of these things without spending a dime until you know it works for you. So when I go to this instance, here is where I was talking about workflows. So I had an empty database instance. What did I do? I ran a few workflows. I did dataset ingestion. So we have some ready-made data. So here I used Coco. It ingests some number of images, and Coco dataset comes with annotations and some embedding. So I ingested that. There's a Jupyter Lab instance that essentially, it connects to your database, so you can immediately start writing queries if you want to do Python queries. Then I ran ingestion from Google Cloud storage, a bucket, and then I did embedding generation. The embedding generation code, essentially, I ran it for PDFs and videos that were stored in ApertureDB. So now, what does the data look like? What does it mean to deal with multimodal data? What did I click on? Okay. I was told the internet could be slow, so don't mind that. So what you see here, I think I mentioned that we store metadata and a lot of information in a graph database in ApertureDB. So this is kind of showing you all the different objects that were created, and you can see that there's a video object, there's a blob object, and they have different attributes. You can index any of these and do normal, like any sort of graph queries, and you can see connections. You can see bounding box to image connected from bounding box to image. So there's all this information that you can traverse these relationships and go explore your data. You can also have attributes on the relationships, so you can filter and only go to the data that you care about. Now, in our UI, even without writing code, you can actually just go to image, video, document, and then do your custom queries. So this essentially, I could introduce any metadata constraint if I wanted. I can navigate my image data set. You can actually see annotations that are part of this. Because I ran embedding generation, you can do similarity search on this. The same way, you can go to the video tab, search for videos, and it works the same way for documents. So you can imagine you've stored so many different data types, and you actually have a way to look at them and start navigating on what they actually contain. Videos might take a little longer to load here because I didn't preload them, and my Wi-Fi is probably coming out. But the demo worked, so. And this is live, you can tell. You can also do things like semantic search. So you can actually type a query. So let's say, what was I looking at? Sandwiches with a lot of cheese. I should have checked for a pizza, huh? So what are we doing? So in this case, we used OpenAI's clip model to embed images, videos, and documents. And the search essentially is looking with the text on all three of them. So you are actually using text to search across different data types. And hopefully it's going to load soon enough. But it was faster when you have better internet and not going over VPN. While that loads, what I want to show you is some. I have a movie database loaded here, and I had some really cool queries. No, that's not the database. Production company. Okay. So if you go, you can actually on this dashboard write custom query suite. So our query language, the fundamental query language that we built this on, is JSON based. And what I'm doing is, like, I have actors in this database. I have movies that they were in, and actually the movies have posters. So I will look for a specific actress here, the movie that she was in, and the posters for that movie. So if I run that query, that's where you can see how I navigated the graph to get to the data I want. And for the same data, I could actually do vector search to get to related images that look similar. So if I went on, let's say, this movie, and you can see that you have annotations represented here, and you can do the same sort of similarity search query to get to other movie posters. I could do queries like find all the smoking scenes in the movie. I remember that query because someone said that's the kind of clips you cannot show in advertisements. So there are all these things that, because ApertureDB by default understands different types of data, you can do, you can show some of these aspects directly from the UI itself. And you can do all the same queries in Jupyter Notebooks as well. So I think the query I ran on the images, it looked for the sandwiches, it went and found, so this is kind of cool, it's actually someone preparing the sandwiches. And apparently Shakespeare has some reference to cheese or sandwich, or one of the two things, or cooking. So yes, so that's like a quick preview on what you can do with ApertureDB. There's a lot more that, it's hard to cover. We have integrations with Llama Index, LangChain, a lot of the the tools that you might need, and you can try it out pretty easily for yourself. And where we are going, we already have built a lot of these AI workflows. This summer, we've launched 12 new workflows to help you do different sorts of processing, ingest different sorts of data, and make it really easy. We have plugins, so we have our own MCP server. We now have a compatibility layer with SQL, so you can actually connect to different BI dashboards with data that is in ApertureDB. We have a query UI that I actually showed you. So now the thing we are very excited about is building the agentic memory layer on top, because we have all the underlying infrastructure to support it. So that's a lot of information for today. You can scan that QR code. Please give ApertureDB a try. And Denise reminded me to remind you all, if you try ApertureDB, share your feedback with us. There is some cool prize. I haven't been informed what the prize is, so I can't tell you. But definitely give it a try. We also have a Slack channel that you can join and ask questions to my team. And yeah, if there are any questions for now, I am ready to answer them.
Very cool presentation. Thank you so much. I'm wondering, can you deploy ApertureDB locally?
Yes. We have a community edition for just testing it out. But if you wanted us to do like a cluster level, the community edition is not the distributed version. It's not the enterprise supported version with monitoring, logging, and all those things. But if you wanted that, we can deploy it locally.
Anyone else? Okay, we'll take the last one and then maybe like a 5-minute break as we set up for the panel. Food is here, so I hope you guys are hungry.
How do you guys stack against VB8, for example?
How do we what?
Stack against VB8.
The performance comparison we have done compared to VB8, we actually were more in the 4 to 6x faster range for vector search. VB8 does support a lot of the richer attributes and text search, but so we have the full property graph to put whatever attributes you need, so we're not limited in what attributes and how they're connected to each other. Full text search, we have some amount of text search support, but we basically introduce things as our users ask.